Namaskar, this is Suraj Singh, professional engineer. In continuation to my civil engineering buildings practice videos, this is the second one that I was explaining to you about the formworks, and I'll continue on that. Please have a look on this book. These are the formworks about major structures. You can see it that way. All massive designs, all massive woodwork in this is an indication of how complicated it looks in practice on site. It looks very complicated, but carpenters can easily do it. It's no big issue. Just for the purpose of short drawings, we do it. And if you go to the other one, you find the same here again. It's really light actually in the book itself because of this problem, but it will be just a sloppy information. And if you see this the integrated one, there is a plan showing the dimensions of this big structure of column and the complete projection of the woodwork, formwork. You can see all buttons, scantlings, supports, clamps, positions of grids, and all components, parts that are required for the formwork construction, formwork temporary works. It's very important from construction viewpoint because temporary works are very headache for every engineer. These are not fully available in the books or in text. It is only based on the site experience that can be carried out on site, and it gives you pleasure when you understand yourself how to produce these formwork, these temporary arrangements on site. See this another example of the same. This is also very complicated, very complicated, but if you see, it looks complicated, but it's not that complicated. You will see all the parts as I showed you before. All the same parts are shown again and again. All the same shikanjas, clamps, timber, vertical, horizontal sections, nailings, dotted lines in horizontal that indicates vertical distance between the two battens, two pieces of timber, that is 75 by 75, 50 by 50, depending. Vertical spacing is 500 mm. Horizontal spacing is also 500 mm. There is a peg on the top for the purpose of nailing the plumb bobs. You can see a wall here. This is a part of a wall. It's typical. You can see the tie rods, tie bolts between the two sides of the two shutters. You can see this is the ply here. Both sides is shutters. These are tie rods. There are tie rods here. There is a sleeve. Tie rods passing through the PVC sleeve. PVC sleeve shall be left in the concrete while tie rod shall be taken out. The hole shall be filled up with the low shrink compound, low shrinkage compound, special material, special chemical. This is very interesting. Support has been shown only on one side because when you are using tie rods or tie bolts, one side supporting arrangement is okay for the purpose of keeping the formwork in position. Top supports are okay, and for the purpose of holding the concrete pressure, middle level supports are okay, while top and bottom supports are meant for the purpose of keeping that in position. This is very exemplary and very exclusively important. Nowadays, more advanced works have been ready, proprietary systems are ready. You can see the elevation of this. You can see this in the elevation here. This is the elevation, and you see here. Looks like this. It is. You can see the same system in elevation as well, but with supporting lines showing. I have not shown the timber for the purpose of clarity. And these are the locations where supports will be formed. You can see two lines here, and one in the horizontal here. This is another one, and this is the third one. This is about a wall. It was about 15 centimeter thick actually when I did it. I put it about. And you can see another one, same type. It's also very complicated arrangements, but complication is civil engineering. Things look complicated, but work is done one by one. Assembly is done one by one. That's interesting part of civil engineering construction, particularly in buildings. It's the same. Again and again you can find the same type, which is very, very interesting. Very, very interesting. Same type, but from different aspects of work. Now you see a plan here. A plan of lift. You can see this lift now. Elevator we call it. It is a big elevator. You can see that elevator, size of the elevator is quite considerable. And you can see the inside supports arrangements in the lift forms. You can see the inside arrangements, which is very, very complicated. And I have shown a dotted cross inside, dotted diagonal cross, which is showing the open arrangement, openness in the lifts. Now, you see this, if you see typical size arrangements of the lift. Same type of arrangement actually. No major difference except that the big members are used, big size members are used, considerable size of members are used, and you can see at different locations there are very cross members around the wall. Very many cross members. These are actually tie rods and some concrete blocks, long concrete blocks we used. We fabricated long concrete blocks for the purpose of holding the two shutters in position of 300 mm or 400 mm, but the size should be 300 mm, I remember it was. And the most important problem was the door of the lift. How to shutter that? Because that's opening in the vertical position. This is that. For this, an additional box out was fabricated to keep in that, in addition to holding the shutters, so that the portion of the door is wide. There should be no concrete in that portion. So that additional shutters were fabricated. That was the most interesting part of that, and it was fabricated by the knowledge of the foreman. You can see the elevation, another elevation of this form. It's almost the same. Arrangement is typical, but just I have shown for the purpose of information, so that the confusion be cleared. That is very important. See, similarly another one. I'm showing you from the top because it's a little fit. The study. It's not very, very good, very, very clear, but this is due to the print problem, the book printing problem like that, and it is almost actually. You can see the other one as well. Let's see. I'll take the other one because this is a little pretty. I don't feel happy here. Let's go to a little better one. This is a better one. You see this? I'm just taking it up and down so that little better is. I'll take it more closer now to the page and scan on that. You can see this. I'm scanning over this, and you will see the numbers in position, and you can see dimensions as well. This is what it is. I shift to the next one. It is the top scan, full scan. Now I'll take it down for a better scanning of the view. See this? It's okay, man. It's also the same. I'm just trying to make it understandable so that you guys know how the works are carried out. Temporary works particularly, that's the most very important. These are carried out in the field. Keeping in view the common sense, utilizing the common sense. That's very important. Let's go another one as well. You can see this other side of the form, and I shall take you after this to the box position where lift gate or lift door exists, where we insert after fabrication an additional form box, which is here. You see this sketch, you can see very well that this is the box for the door of the lift. You see the plan, this is the plan of that. You see the plan, and this is the door. Additional box for insertion within the formwork itself, closed formwork, and this is inside the closed formwork. This is like a door. If you see the sides, this is the side of this. It's very interesting, and this has to be given double supports. Support is very important. This is the only way to carry out formwork within formwork for the purpose of blockouts or voids. This is really interesting from practical viewpoint. You can see elevation which is written here, typical. Go to the other one now. It's another view. This is a formwork for a column. Formwork of a column of 5 sides. 5 sides formwork of a column. This is interesting design. Maybe it is a remote, rare, but in architectural design it's available on many projects. It's ornamental type work, and formwork is also on the same pattern. You can see all the 5 sides are typically oriented. Formworks have been implied similarly, accordingly, and you can see the locations of the plumb bobs, stone plumb bobs, and typical supporting system is there. I have shown it just for the. You can see this is a thread line. Thread line here. This is a thread line for the reference of measuring from the ply to the thread distance, and that can be a practical check on this formworks. I will show you the 6 sides now, hexagonal. It's also very important. It's hexagonal. It's also available on many buildings. These hexagonal 6 sides is symmetrical, and it looks nice in the elevation. Architects would definitely prefer such types of forms, and for structural design there could be other considerations, but for the purpose of work on site, for the purpose of prosecution of the work, for the purpose of execution of the work, this is also very, very interesting. You can see various lines are shown. In both cases, if you see the 5 sides, you see the lines are inside. You can see these lines. How to locate these is very important. And here also it is the same. There is no major difference between the two. The difference is for work on site. These types of formworks require little direction and supervision on the jobs by the supervisors or engineers to the foreman or to the junior staff on site. It is very, very essential from practical execution viewpoint. I will go to the other one. This is also 8 sides now. Little more complicated arrangement. Though it is 8 sides, but it will look like circular one from far distance due to the nature of the geometry, and it looks nice here because there are additional arrangements in this, keeping a square as well as getting additional supports, additional fabrication spares, frames. It's a little complicated, but experienced foremen and experienced charge hands can do it very well. This is This requires regular supervision, strict supervision, and control from the settings of the columns and plums. You can see the diagonal internal connections as we said before. These types of columns are not very often, but on certain villas or on certain, you can say, palatial works, these would be available, as architects are fond of such geometries on the structural arrangements. These are very, very important to know in case you meet in your life sometimes. For such structures, you should know how to tackle the requirements, tackle the demands, how to meet the demands. That's very, very important. Can we go to the other one, which is also complicated structure, an obtuse column. An obtuse column. You can see it obtuse, and all the arrangements have been fixed accordingly. All the arrangements have been fixed accordingly, except these are not square in position. Just all arrangements, all lines, all fittings, all plumb bobs, all wood members, all timber members, all supports, all pegs have been following the obtuse direction, and that is what is required. Well, the principle you have understood, you might have understood by now. It is clear to you, I'm sure. These are for close supervision. Without close supervision, such type of formworks cannot be erected as temporary members, temporary systems for receiving the concrete successfully. One has to be sure about controls, horizontal controls and vertical controls, because such structures are based on controls. Should there occur any errors, that will not help the structure, that will culminate to other structures. Therefore, these are quality works, quality control works, very quality in all respects. Let's go to another structure. It's a wall fascia. You can see very well, it's a wall fascia. Means it is section is shown as vertical. You see the slab in between, and bottom fascia and top fascia. This is a fascia work. This is used for the purpose of insulation of the room. So this void between this void, you can see this void. This will form a void, and this will form a void. For here there will be blockwork later on, and this portion will be closed. This will act as sound insulation as well as thermal insulation purpose, and it has been shown in details how the formwork is organized for such complicated structures. I have shown this in one go, but in the field it is to be done in 3 goes. First is this portion, second is this with the slab, and third is this with top portion. This is done like that. There is no other way. We have done it accordingly, successfully, because this like fins, it's not so easy. You need patience and tolerance to carry out such structures. Such structures, you may, at the first moment, if you don't know about this, you will feel troubled at how to carry out this. Nobody will tell you, because you are an engineer, and if you are not an engineer, you must know how to do it. Go to the other one. It may look simple, but that's not so simple. You see the full sketch here, or if you see the other orientation like this, this is the orientation. You can see this is the column here, and this is the slab here. This is the slab here. This is the beam. This is the fascia, vertical down. This is the from lower level up to the beam, from the beam into the beam and into these concrete members. This is the column. This is the portion, horizontal portion of concrete. This is the vertical fin, vertical fascia. This is the portion of structural beam, and this is the slab here. You have to cast this in one stage. You have to cast column first, then you have to cast this, then you have to cast this put together. So stage 1 here, after the column, stage 1 here, stage 2 here, with this. That is the arrangement done here. I have shown all together for the purpose of clarity, but sequence is like that only. Now you can see how the members have been arranged in this. You can really see how the members have been arranged. Same pattern, but with different approach, different supporting system, different controls. All modes are different. You have to see the sequence, how it works. Means when we do concrete work, during pouring, all the forces produced by the concrete, by the load of the concrete, by the load of the workers, and also keeping in view how to de-shutter as soon as possible. For example, vertical members have to be de-shuttered the next day, sometimes after the third day. In that case, the vertical portions, vertical members should come out without disturbing the other members, horizontal members. That is the approach, that is the concept that has to be kept while you are designing this formwork. It's not at random you can do anything. You cannot keep any vertical member occupied for nothing, because sometimes you are paying rent, sometimes it is invested. If you are paying rent, you have to pay the rent for nothing, because vertical member can be used for another structure after 2 days, while slab member cannot be taken out for many days, say for 10 days or 7 days. All these points are kept in view while designing such temporary structures. Now we'll go to the other one. That is another kind of, see, another design. It's you can see yourself. It's a vertical fascia of a high-rise building. There is U-shape. You see, web is longer than the flange. Well, I'm just using the term for explanation purpose only. It is from 4th floor to 18th floor as it is in the fair face. And it's a very complicated arrangement. You see, smaller side, how it works. This is a smaller side. How the arrangement has been done. It has been done as it was done in the wall. It has been done in a similar pattern. As it was done in the wall. And if you see the other longer side, it has been done accordingly as was walled. Because you have to see in this type of structure, see the other side, how it is done. Now the main control in this is, you have to pour all the 3 sides. And there is a chance of differential pressure while you are pouring. You have to avoid that differential pressure. This means you have to pour a whole member in smaller thickness layers. So 40 cm, 30 cm, and then 30 cm, and then 30 cm. You have to rotate on this whole structure. Otherwise, you will find a different experience. There are chances that one side could bulge while the pressure is different. So it requires a higher degree of attention and care. Well, until you have experience, you may not understand this, but this is very important from construction viewpoint. Now we'll go to another one. It is also a different type of shutters. It is plan of a stairs. You can see there is a landing in between, and very easily you can understand this. It's very black page actually, that's the problem. Maybe it's not clear, but if you scan over, you will find I'm scanning for you. The scanning is overall, and all is there. Let's go to the other one. This is what the stair is about. You can see this. It's very faded sketch actually, but maybe you are able to see this because this is mobile I'm using, and all these vertical supports, all these supports are being cut in that, and there are also supports for the stair. So actually, you see now another sketch. There's on similar patterns. Maybe you are not able to see, but it's not that difficult. It can be carried out accordingly. Put another one, but now here's a better one. This is a slab, a suspended slab, and you know what suspended is. Suspended doesn't mean hanging. It's suspended on 4 sides or 3 sides so that moment of resistance and bending moments are created. The moment of resistance is provided to resist the bending moments. Well, that is a part of structural engineering, but I am just showing you about the slab arrangement. You can see the panels and the beams. Vertically and horizontally in both axes, x-axis and y-axis, there are beams. These are to be shattered, and there are bays. You can see this is bay, this is bay, this is all beams. This is all beams, and these portions are shown just for a typical arrangement. Also, this portion is typical arrangement, and this is the axis line, and these are all closing lines here. This is the arrangement. If you see, this is the section here. The section here. How this is done on site, the general arrangement details of a suspended slab. How the work is done. This is the arrangement. This is very, very typical, and this you have to do anyhow on every building. You see the other one? You can see this. The big detail here. It's very complicated detail. I'll show you, very black but complicated. Very complicated arrangement. Section is shown. The drawing is little black, so it may not be 100% visible. But this is shown as a section, small section, very very small section, and you can see the other details. And I'll take you the other sketch now. Now these are the sketches, various sketches in a building, which I just viewed comes as a concept I visioned, and you will see in the next video about this. And before that, I'll try to show you one first, we can say one isometric about conceived building. This is, you know what it is. It looks like a toy, but it is of the shape of a small aircraft. This is a building. This is a conceived building, hypothetical design, and it is like the architectural research work on a plot. And this is a complex for a hotel, can be utilized for a hotel. And you can see this is a building in airplane shape, while there is a car park here. In building, this is the car park here. This is the car park connected by various roads, internal roads, and there are smaller buildings here. This is a smaller building. This is substation and generator. This is generator and this is substation. Also, this is a pergola to sit in the open, in the shade, and this is another smaller building. This is, you can say, swimming pool here, and this is tennis courts here, tennis playgrounds, and you can see here entrance. This is the entrance, and this is the guardhouse. This is another swimming pool, and this is another room for services. This is another pergola, and this is over a tank. The dimensions of this is about 235 meters this way and 305 meters. This is this point to this point is 305. This point to this point, this point to this point is 235. I'll explain again. This is 235, and this is 305 meters. So you can just multiply both and see what is the capacity, what is the size. This is 7.675 hectares, and I have used floor area ratio of AR is 1.464 or 146.4 percentage. Ground coverage is 19.67 percentage. This is a model design, and I did this in 1992 as a part of my thesis in town planning engineering and civil engineering. But I have done like this about 55 complexes, and if you see further details of this, you can see here. First of all, let's take a view like this so that it gives clear view on your monitors. This is the clear view of your monitors, and if you see the other one, this is the line plan of this building. This is the line plan of this building. This is pillar actually. This is a basement, you can say. Basement. I use the graph paper for working on this. And this is the plan. And if you go to the other one, that is further ground floor, which is showing on the floor a welcome sign in decoration purpose as a decorator, and a fountain, and a dance disc also, circular dance disc on which people can dance, and this is stair arrangement. This is also a line plan on the graph. This is a line plan here. This is the entry, and this is the circular portion here, curved portion, and these windows are stepped for both sides. And if you see the first floor arrangement, it is also the same shape, except the rooms have been divided. You can see there is a corridor in between on both sides, and these are the rooms, stairs, and fountains. It is a typical design for all the floors. And if you go further, you will find different types of floors. I will show you another building just for the purpose of ending this video, and that is a pistol shape. A pistol shape building, other orientation, and also in the other orientation, in that orientation. So all of you can see